Mark the test specimen with marker pen with length 900 mm. After that, label both mark with A and B. From support A, mark a distance with 100 mm, 200 mm, 300 mm, and 450 nm. Hang up the weight scale at the upper connected scale, and after that, hang up the test specimen with suspender at both weight scale. We need to install the rider at the test specimen, and we need to move the rider at distance of 100 mm near the support A. Switch on the weight scale and set it to 0 value. Put the weight of 15 Newton at the weight hanger. After that, hang up the weight hanger at the rider at 100 mm distance. Read and record the result at the weight scale at both support A and B. Repeat the step at the above for the difference distance, which is we need to change it to 200 mm, 300 mm, and 450 mm. Discussion first, we need to compare the results of this test for each specimen to the calculation of standard value, which is we need to compare the reaction force, bending and shear stress. Comment any difference and possible sources of errors. How does the relative importance of bending and shearing stress vary with the loading position of the beam? Based on the results of the experiment, would the steel be stronger than the brass? If so, explain. Is there any difference between the stress measured at the top of the beam and at the same location on the bottom of the beam? Explain the both possible answer. Write and define the classification of beam. They must be shown in correct diagram. In conclusion, we are able to determine the reaction force, maximum bending stress, and maximum shear stress in straight beam for this experiment. We are also able to know that there is a little difference in reaction force value between theoretical values and calculation values for a loading on a straight beam.